We're going to talk intelligent design, creation, evolution, and artificial intelligence. This is Genesis Week. And welcome to this episode of Genesis Week, the weekly program of creationary commentary on news, views, and events pertaining to the Origins controversy, made possible by you, the supporters of Core Ottawa, Citizens for Origins Research and Education. Excellence in pirate broadcasting. We are coming to you live from our studios at a top secret location not far out of Squirrel Depot, Ontario. Al has taken the day off today. However, I am joined by a guest I have very much looked forward to having on the show, Jonathan Bartlett. Many of you may already know him indirectly because John actually is the one who told me about and put me on to, what did you call it, where a computer program programs itself? Metaprogramming.
Yeah.
Metaprogramming. And John actually has a lot, he's self-taught in genetics of all things. And there's reasons for that, but his computer programming background is what, he makes a lot of brilliant analogies between genetics, which is basically a code. It's a computer program on how to build you. And John makes a lot of brilliant analogies. John thinks a lot outside the box, and I really, really wanted him on the show for today's topic. We're going to talk about intelligent design and artificial intelligence. And when I asked John about his, for his bio, because I couldn't find one online, he just said, oh, I don't really have one because he has an unusual biography. And I agree, he is well-versed, but he is a multidisciplinary academic with the Blythe Institute, having published work in mathematics, biology, philosophy, and information theory. His books have been used at institutes as diverse as Princeton and DeVry. By the way, that's very interesting. I did not know that before yesterday. He's also a writer for the technology blog mindmatters.ai. And he also has a day job of programming user interfaces for remote control construction machinery. Basically robotics, right?
Basically, yeah. They look like little. It actually looks like the kind of the tank things from Terminator 3. So.
Excellent. And have you put AI on them?
We have not put AI on them yet, but we've thought about starting the robot revolution.
That's right. Skynet rises. Yes.
Exactly.
The Fallout video game fans are just like, yes, bring it on. So this morning we're going to talk, as I mentioned, we're going to talk about artificial intelligence, and I really appreciate John being on with me today because he is such an outside of the box thinker, and he always brings a different perspective, usually one that I'd never encountered before, never thought of before. And so that's one of the reasons I really wanted him on. And so, John, if you don't mind, and for the sake of those watching the live stream, I'm going to give everyone a crash course in AI, what it is, how it works, because it'll be important for everyone. Is that okay with you, John?
That sounds great. One thing I want to correct, though, is that I'm not really that much of an out-of-the-box thinker. What I am is I'm someone who reminds people what the box actually looks like. Because
see, but that's out of the box thinking right there.
Yeah, well, people try to cheat all the time on what their box actually looks like, and I just sit there and I remind people. I'm like, no, this is what the box looks like. This is the box you've described, and therefore this is how it has to fit if your ideas are going to be correct.
I love it. Okay, so pray for me. we're going to get a crash course in AI. I'm going to try and do it in under 3 minutes. Okay. Artificial intelligence is an attempt to simulate human intelligence. And I'm going to explain it by doing something that you humans do every day that you never even think about. And so you'll see diagrams like this of neural networks. It's an attempt to simulate the layout of the brain because your brain is composed of neurons, which are all interconnected. And so you can have tens of thousands of connections between trillions of neurons in your brain. And so this is an attempt to simulate how the human brain works. Bearing in mind, we really don't know how the human brain works. So with that in mind, what we're going to do is we're going to challenge the computer and the AI to do a simple task that we do every day, and that is read handwritten scribbles on a piece of paper. So what we got here is a scribbled number 7 on the piece of paper. The AI is on a computer. Computers only deal in numbers, ones and zeros. That's it. It does not know it cannot use ink on a paper. So what it has to do, first of all, is we have to convert the ink and paper into ones and zeros. We do that with a camera. You as a human being do it with your eyeballs connected to your neural network. In this case, I've got a camera which is 5 pixels wide, 10 pixels high. And what I've done is I've taken the pixels. If it's white, it's a 0. If it's black, it's a 1. And so what we're doing is we're converting the pixels into ones and zeros. And you can see I've got the rows here, 1, 2, 3, 4, 5. And I've taken all the rows and put them into a vertical column. 1, 2, 3, 4, 5. Then the next row, 6, 7, 8, 9, 10. 6, 7, 8, 9, 10. And you can see that these 4 are indicating black, which I've indicated here. Our ideal number 7, if we're trying to detect the number 7, handwritten number 7, our ideal number 7 would fall within the cyan pixels that I've marked out, which I've also marked out in the column. So these are our input nodes for our neural network. So now what we do is these are, they call them neurons, or what's another word they use for them, John?
Nodes.
Nodes, thank you. My brain just went blank. So these neurons, basically they're connected to all these input nodes. And so we have a neuron that reads black, and just as important, a neuron that reads white. Ideally, number 7 will land within the blue squares, the blue cyan pixels, and all the others will be white, ideally. It's almost never ideal. So what it does is it looks at what is expected, what it hopes for. The black ones are picking up which pixels are seeing black, and it basically performs math calculations. So the first thing I want to point out to everybody, these are basically, it's like a pocket calculator. It's a teeny tiny computer program. It's statistics. That's it. All it's doing is taking statistics and doing statistical calculations. That's it. And what it's doing is it's looking, okay, it's expecting 12, it's looking at 12 different inputs. And okay, 9 of them match. 9 out of 12 are black. And so it has about a 75% match. The white neuron is looking at all the nodes that it's expecting to be white, if it's a number 7. And it's looking at 28 different pixels, 27 of which match. And so what it does is it performs a mathematical calculation. And so it then passes those over to another layer. And so in this case, the layer is for the number 7. It's expecting a match between 65 to 100% for the black and 75 to 100% for the 7. It performs more math, bearing in mind, these are all just calculations, because that's all computers deal with. And it comes up with a number. This is its best guess. It has about an 85.7% match to the number 7. Every single one of these output nodes has their own calculations, their own numbers. And so what it'll do is, I'm going to skip over that. It'll run through the calculations. For each of the numbers, it's a likelihood of 5.7% that it's a 0. It's almost a complete poor match. Might be 54%, etc. You get the idea. Number 7 comes out on top. So its best guess is that what it's looking at is the number 7. Now, of a critical importance here, what it's done is it's popped out its best guess. The goal is to get the correct answer most of the time. What it does now is there's a very critical step here. Somebody, a human being, has to tell it whether it is correct or not. Very important step. So if it's correct, then all is well. If it's not correct, then there is another step in the process. And this is called training. So basically, there's another neuron over here, another tiny computer program, that can come back and it can fidget with these numbers. It can make the match wider or narrower on both of these. It can also perhaps change these numbers here, the statistical calculations, and what's acceptable and what's not. And so the idea here is to formally train it further. But how did it get all these numbers to begin with? Well, when they first start up the AI, what they do is a human being trains it. And so what they'll do is they'll put it in training mode and they will run dozens and dozens. They will scan dozens and dozens of samples of the handwritten number 7. And so it will read it and build up these statistics. So this is a very important point here to understand. When you see neural network overviews, you can start to see, here's all the middle layer nodes, here's all the second layer nodes. In that case, it was black and white nodes. And every single one of those numbers on the output layers each had their own black and white neurons, their nodes. And so what you have here is this network where they're all interconnected. You can picture these as pocket calculators, because really that's all they do, is they're just a little teeny tiny program. All it does is punches out numbers. So the main points I want to leave with you all is there is no cognizance here. There's no cognition here. There is no self-awareness. It can't be any more self-aware than a bunch of pocket calculators all connected to each other. And it can only do what you tell it to do. Someone has to tell it what is the correct answer, what is not. Okay, was that under 3 minutes? That probably wasn't, eh?
Have you seen the movie Short Circuit?
Oh, I have. Of course, that was a classic.
Yeah, so one of my favorite lines from that is it's a machine. It doesn't get happy. It doesn't get sad. It doesn't laugh at your jokes. It just runs programs.
Yes, and punches out numbers.
Exactly. One of the things that I tell my students are like, there are literally like, you can run an entire computer that only has one instruction. You can has all the power of every computer that exists, and that one instruction is subtract and branch if negative. And you can use that one instruction. What makes computers exceptional is not that they do anything interesting, is that they do it really, really fast.
Yes.
And so if you have like a standard 3 gigahertz computer, what that means is that it's performing 3 billion, that's billion with a B, math calculations every second. Now they're all simple math calculations, but it is literally just performing math, and that's and if you think about everything that happens is just addition, subtraction, comparison, and picking a path based on comparisons, and that's everything that a computer can do.
Bingo. Yes. And on that note too, when it comes to artificial intelligence models, So we have all these nodes, neurons. They go by a variety of names depending on who you're talking to, like me, because I tend to mix up all my terms. But what you're looking at here is all of these nodes, even my little teeny tiny example of this one, if I were to actually build this up, this might be like, I think I've worked it out to like 90 or 95 nodes approximately, is what it would take to actually build this out. Not a lot. But the Llama 2 model, which was just released. You can get it from Meta. You can download it yourself. Just to give you an example of some of the size of these, how many of those pocket calculators there are. The Llama 2 model you could download from Meta, the Facebook company. They made it publicly available. You could choose the 7 billion node model, 13 billion, or 70 billion. Take your pick. But that gives you an idea of some of the size. But again, stringing more pocket calculators together and connecting them does not make it more intelligent.
Doesn't make it conscious.
It's like a what?
It doesn't make it conscious.
Bingo. Yes. Now, on that note, okay. Do you want to add anything before I go on?
I think that's pretty good. The other thing just to mention is that the fact that it's done on a computer does not add any additional interest to it. This is basically math equations that you could perform with pencil and paper, and the fact that we're using a computer means that we can make more of them faster, but it doesn't actually expand the capabilities. So basically any of this stuff you could do by pencil and paper if we had enough pencils and papers.
Right. That would be a lot of pencils and papers.
Yeah.
So,
for those of you who caught the live stream with Joseph Jordan and Guy Malone and were intrigued by the topic of aliens, UFOs, and how they fit within the biblical and creation science context, Ian put together a mini-series just on that topic. This 4-part special report contains a deep dive into the shockingly common UFO phenomenon and even more shocking phenomenon of alleged alien abductions. You will walk through what both the Bible and scientists have to say about aliens, and surprisingly, the theologians and even atheistic scientists agree on what these alleged aliens are. This mini-series is available on a 2-disc set in either standard definition DVD or full high definition Blu-ray, and is now on extended sale until December 10th. You can order your hard copies today on the store at ianjuby.org.
okay, so I think hopefully everyone can start to grasp what, because John already knows where I'm going to be going with this, because in fact, let's bring this right to creation and evolution, right off the top. So, according to the theory of evolution, we are the result, our brains are the result of unguided, so basically random, natural processes over billions of years. So, John, you will know where I'm going with this, but let's take it and run with it for a second. Is it not simpler for a computer with a program of an AI program installed on it, is it not simpler for that machine made out of rock, basically, would it not be simpler for that to evolve by natural processes rather than the human brain?
Oh, for sure. The simplicity of the computer it's massively simpler than any cognition or really any cell.
Mm-hmm.
If you even take brains out of it and just go for just a straightforward amoeba, those things are massively more intricate than a modern computer.
Yes, and if it had an artificial intelligence, a really super smart one, on board, somehow miraculously, because it would be miraculous, would it be I'm trying to figure out how to put this question. The point I'm getting at, of course, here is that intelligence only comes from intelligence.
Mhm.
So these artificial intelligences, is that a word?
Yeah.
Cool. Okay, so these artificial intelligences, they only came from an intelligence. Very, very smart people put a lot of effort and a lot of intelligence into it just to make them as smart as they are. But is it a fair argument, do you think? I would contend we can never develop an AI that will be as intelligent as a human.
I think I think that is correct for a number of reasons. There's actually several theorems in computer science that kind of show the limits of what you can do. But one of the more interesting things is um, there are limits of what computation can do, and one of them is uh, analyze. There's an extent to where you can't program a computer to analyze a computer program in the same way that a human can. It's known as Rice's theorem,
Right.
and there's some nuance to that we won't get into. So, for example, you can program in specific cases and specific classes of cases, but those all have to come in from outside. So
Right.
as a programmer, like I can't program a computer to figure out what all those cases are. I have to know them and bring them in.
Okay, excellent example. Okay, and the analogy I made was, of course, with what was the name of that computer? The supercomputer that beat the world chess champion.
Big Blue,
Yeah, it was Big Blue.
I think so, or was it Watson?
I even wrote it down. But do you think I could find it now?
Probably not.
No.
I think
I
it was
even wrote it down, and okay, I think it was Big Blue. Anyway, so Big Blue, the supercomputer, they program it to play chess. It beats the world chess championship.
Deep Blue,
The world chess champion. I think it was 1996. I think it was.
something like that. It was Deep Blue.
Deep Blue. That was it. Thank you. So Deep Blue. Deep Blue beats the world chess champion. It was a watershed moment. It really was. Because the computer actually beat the human at the game. So the analogy I make is, okay, great. Does that mean it is more intelligent than humans? I would contend not, because let's take Deep Blue and stick it to the controls of a 747 jumbo jet. What is going to happen? Bad things are going to happen because the human intellect is vastly superior, because it's way more than just beating it at chess, for example. ChatGPT probably wouldn't do a very good job at running a 747 either. So, anything you want to add to that?
Um, one other note. You're totally correct, but there's also something else that a lot of people don't realize, and that is computer controlled systems. Sometimes they seem impressive because we use them to do kind of the high intellectual things, or the things that we consider high intellectual. But what most people don't realize is that a lot of those things are just systems that run on math equations already, and that we're just teaching it the math equations. The things that are actually really, really, really hard for computers are kind of the basic things, like, how to get a stain out of a rug. That is
Right.
actually, in fact, most people don't know this, but just to hold an egg was a robotics problem without breaking it. Was a
Yes.
robotics problem that was literally only solved, like, I think 2 years ago.
Right.
And so some of the basic just getting along in life type of situations are actually much harder problems than the ones that seem like they're kind of the what seem to an ordinary person as a hard problem are actually the easy problems for computer programs.
Yes. Agreed. And so coming back to what we were discussing a moment ago. So this principle, coming back to creation and evolution, I would contend that any created intelligence cannot be as intelligent as its creator. And any intelligence demands a higher intelligence creator. Would you agree with that? Or do you...
No, I generally agree with that. I would say same or greater, just to be like, I don't know that you would have to necessarily be lesser, but at most the same, probably lesser.
Gotcha.
Basically, there's conservation of information theorems that say that you have to align systems with what they're going to do, and that's literally takes information to do that. That's what information is this alignment. And so you can't align a system if you yourself don't have the information to do it.
Thank you so much for joining us. We're going to call that a wrap. And please join us again next week as we continue this fascinating discussion into artificial intelligence as it relates to creation, evolution, intelligent design, and the question of origins. And in particular, the question of the origin of intelligence. Fascinating topic. Hope you'll join me again. Remember, check out our social media pages to find out when the next live stream is, so you'll be able to join in the chats and jump in the conversation. I will leave you with the words of our Creator, the hyper-intelligent Creator, our Lord Jesus Christ, who said, "I am the way, the truth, and the life. No man comes to the Father but through me." We'll see you on the flip side.
You can send your comments, questions, hate mail, and letter bombs to us in a number of ways. You can email comments at genesisweek.com, or you can tweet at GenesisWeek. Or leave a comment on CORE's Facebook page at CORE Ottawa. Or leave a comment on the appropriate show available on either the Rumble channel, rumble.com/user/IanJuby, or on the YouTube channel, which you can easily find by going to wazulu.com, that's Ian, and that'll take you straight to the YouTube channel. But just remember, these shows are now recorded live, so you'll want to search out the show under the Live tab. We need your support to keep this program on the air, so please pray for us. And if you wish to financially support the program, Canadians can make a tax-deductible donation via PayPal online at ianjuby.org/donations. Or you can mail a check written out to CORE, Canada North, Post Office Box 72075, Ottawa, Ontario, Canada, K2K 2P4. And thank you for your support.